Hello all, in this video I am going to run through the theory parts and few examples related to 14b and c, defining the circular functions sine, cosine and tangent, and some calculations based on these circular functions. Okay, let me run through first couple of examples here. Before moving into examples, let's define the circular functions. What is sine and cosine? Well, you probably remember we worked on the unit circle to find the radians. Now what we are going to do is we are going to walk around this particular unit circle on the circumference in red. Let's start with the point here on the x-axis. I'm going to call this point as, I can call anything, let's say A. And then the point here, I call it B. And the A has 1, 0 coordinate. B has 0, 1 because it's on the y-axis. Then the other one is C. I'm calling this one as C. The coordinate is negative 1, 0. The final point that I'm going to consider is D. That will have the coordinates 0, negative 1. Now, let me say I am at point P. So the point P is on the circumference and subtending an angle theta radians at the center, which is in this case O. The coordinate is 0, 0. The definition of sine, this is very important. Sine is, we call it sine theta, is the height of the point P. Cosine is the length of the point P. In this case, length means the horizontal length, the x value. Now, if I look at point A, if my P is at point A, I am not going to subtend any angle other than 0. So in this case here, let me get a different color. Just in there, I have theta as 0 radians or even 0 degrees. What it means? Well, if I call sine 0 mean I am on the x-axis at point A. What is my height? Well, sine is the height. My height is just 0. Therefore, sine 0 is 0. Well, what is cos 0? Cos 0 is the length I am away from the origin, which is O here, to A. The full length here is the radius is 1. Now we found two values. Let's walk around and then find the answers. Now at here, what is the angle that I am going to subtend? Let me get a different color again. At B, so that's the point I am looking at. The angle that I am subtending is 90 degrees. Can you see that? When you walk around nicely on this circumference, that is the angle you are making. That's what we call the angle subtended at the center, 90, which means then for us, if I say the height, what is the height at 90? The way we ask using circular functions, sine pi on 2. Pi on 2 is the angle, sine means give me the height. Okay, what is the height? Well, you guessed it, it is 1. Well, I'm going to ask you this. What is the meaning of this? Cos pi on 2. Well, give me the horizontal length away from the origin at 90 degrees when I walk around the path here in red. Well, it's starting from A, of course. Well, you can see I'm right on top of O, the origin, which means I haven't moved horizontally. Well, likewise, I can go to the other side. At C, I'm going to pull a different color here again. to differentiate. At C, I'm looking at the height at pi, because I'm going to do pi radians there, 180 degrees. What is the height? Well, there is no height. You are on the x-axis. Well, what is the cos pi? The cos pi is, well, you have moved to the left-hand side of the origin. By how much? Well, it's -1 unit. That's -1. Okay, we come to the last one now. Let me pull this color. Say green. Green for go for all the answers for the rest of the problems. Well, sine. What is that value? I've gone pi on 2, another pi on 2, pi on 2. In this case, 3 pi on 2. I have gone 390 degrees here. All the way. Can you see that? All the way. What is the height? Well, perfectly below the origin by -1. I'm going to ask you this. What is this? This is, what is the length away from the origin? Well, you're just below the origin, therefore no length of horizontally. Now we are going to look at the examples. Let me recap quickly. Sine and cosine. Sine is the height, cosine is the length, horizontal length. Well, that is basically given here. Now we are going to evaluate these values. I'm going to refer to these points. That makes much more sense for us to work on. Sine pi, we looked at that earlier. Sine pi, the angle when it is pi degrees, all the way down here into the left, we have value 0. So there is no height. Cos pi, well, we looked at that earlier, -1. Sine pi on 2, we looked at, that's point B. 1, height is 1. Cos 15 pi on 2. 15 pi on 2. You're going to go 15 pi on 2s, which means you are going to go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 here. You are at point D. So I've done a bit of a scribble, pretty bad. I'm going to undo that. What it means is you need to understand how many revolutions you're going to do before you hit the point that you are looking at. The best way is, I know when I go 4 pi on 2s, I am completing one full revolution. That's what I'm going to look for, which means I am back at A, starting point on the x-axis. That's what we're going to look for. Now let's look at that here with, okay, I'm going to rewrite again, 15. Well, I'm going to have a look at how many full revolutions there. 15 pi on 2 can be written as simply 7 pi and a pi on 2. So simply writing 15 on 2 as 7.5. That's what I did. So in 7 pi, I would have 3 full revolutions and another pi. Now I have 1 pi and a pi on 2. Well, 1 pi means all the way from A to C, and then another pi on 2 at D. So we get the answer. We are at D. That's what we're going to look for, which means I'm looking at the length when I'm at D. Well, of course, it's 0 because I'm just below the origin. Hope you got that through. Now we go a little quicker in these ones. 21 pi. Well, how many 2 pi's in there? 10 of them. And there's a 1 pi left over, which means you are going to go again from A to C. That's where you are. Height will be 0, isn't it? Now cos -17 pi. I'm going to zoom in and put a bracket. -17 pi. Negative mean at the moment we just went anti-clockwise all the way that way, like a spiral into the left. Can you see that? Good. Negative mean you go in the other way, clockwise. Right. You get the idea, don't you? Nice. Now I'm going to go what? I'm going to go 17 pi clockwise. Okay, 1, 2, 3, 4, likewise, right? Well, I better look at how many revolutions I'm going to do. So I'm going to do 8 revolutions, 8 by 2 pi's here, but clockwise, I put a negative for clockwise. And then also I'm going to go another negative pi to make 17. That makes sense. But remember, when you do full revolution, you back at A. So I'm going to circle that all the time. I am back on the x-axis, which means I'm going to go only 1 pi clockwise, which means from A to C, just 1 pi. Well, it's like a face, 2 eyes in it. Right, which means in this case, cos mean the length, you are 1 unit to the left of the origin, hence the answer is -1. Now you get the idea of negative values of angles. You're going clockwise. Now negative sine negative pi on 2, negative pi on 2 mean you go clockwise pi on 2, that's where you are. What is the height? Well, it's -1. You know that it is -1, just below the origin there, or rather the center of this circle now. Well, this is a good one, isn't it? Well, let's have a look. Right, what is this then? I need to look at how many full revolutions here first. So if I divide this one, or rather split this into bits, I get 1000 plus 1 pi on 2 but negative. Well, if we split this again with the denominator 2, I would get -500 there, and it is with a pi, and then I get a -half pi. So it's simply pi on 2. In -500, I would have 250 full revolutions. You get the idea now. You back into original place, which is the point A here. What you all have to do is simply do another pi on 2 clockwise, which means I am just below the origin, which is D. Well, what would be the length at that point? Well, that's 0. That's how you find it. Okay, so we got through these, that is sine and cosine. Great. Let's move on to tan. What is tan? Well, what we are going to do is we are going to look at the same point, the point P. The tan is when you draw a tangent to the point A. That's what I do. I am going to extend the point, let's say this is O, the OP length. See the OP length? I'm going to extend that line until I meet the tangent here at C. Then the height of the tangent. The height of the tangent is called the tan value of that particular angle. Well, as easy as that. Now at A, now I'm going to look at the relationship. There's another one, ladies and gents. We can form 2 triangles here. One is the little one and one is a bigger one, just in there. If you look at them, the angles are exactly the same, which means these 2 triangles are similar. Therefore, the ratio is gonna work. The height here, tan theta, divided by the full length, which is 1. See the full length here for the bigger triangle. Tan theta divided by 1. So the ratio between the length of these sides is exactly same as the ratios here. What is the height here? We define that as sine. The length here defined as cos. There is a relationship here. The height of the tangent is exactly same as ratio between sine value, or the height, and the length of the corresponding point P. That's what we have written here, just down there. just in here. Okay, that's what we did. Right, so we get the idea of the tangent. Now it is the height of the tangent. Let's have a look at what we get here. Well, tell me the height of the tangent here at A, which means tan 0. Well, there's no angle, rather angle is 0. What is the height? 0. In fact, you can see the height at that point is 0, length is 1. Therefore, sine 0 divided by cos 0 works here. Well, at this point, what can you say, ladies and gents? I'm going to draw the tangent all the way up to the sky. I'm going to pull a different color. So at that point, I'm going to draw a line that meets the tangent. Would they meet ever? Well, it's not, because they are parallel. Hence, what we have to write here is, in that case, tan pi on 2, the legendary UD. What does UD mean, ladies and gents? Undefined. You can see there is no height defined for 90 degrees. Same for negative 90 degrees, negative pi on 2. But if we go to the other side, we are going to look at the heights of that tangent on this side. We can find the length and the width for the corresponding point when the P is here. And of course, we can find the height of the tangents. And of course, when you do this, you can see the ratios are having one negative value. The height is positive, length is negative. Hence, it's delivering a negative value for tan. So let's have a look at how we get that one using that height. Well, we are going to extend this one until we meet that height, which is exactly same. So that's negative, but exactly the same height as on this side. Therefore, you gotta make sure when the angles are obtuse or in that quadrant, second quadrant, the height of the tangent is negative. You can't draw to that side. You're gonna extend that OP to this side until you meet the tangent on the right hand side at A. Righty. Let's have a look at another one. Just a point here. Let me get that point here. At pi. So tan pi. What is the tangent height, you think? I'm there. So when I extend my OP meets there, the height becomes 0. Simply, on the x-axis, the heights are 0. On the y-axis, heights are undefined. So the next one that I'm going to look at here is tan 3 pi on 2. Undefined. You can't define the height of the tangent. Right, we had a look at through that. Let's calculate these ones quickly. Tan pi, well, we actually looked at, didn't we? So that's 0. Tan negative 2 pi, you're gonna go full revolution but clockwise. Remember, this way now. Comes back to A. So the point is back to A, which means, again, the value is 0. Well, tan pi on 2, we just discussed, undefined. Well, to get these values, we are going to use the calculator. Let me pull that. I'm going to move around my calculator until I see everything perfectly. Okay, first one, tan 1.2. Make sure your settings, radians, and let's make it real. And for this one, either you can put standard or decimal. Keep it decimal for the time being. Okay, now I'm going to go to trigs. That's where the trigs are. Or you can in fact just go in here in math 1, because we're just dealing with sine, cosine, and tan. So tan, I'm going to punch 1.2. I'm going to pull this up. Okay, 1.2. What is the answer? 2.57. What is my next one? Next one is tan 1.8. Okay, 1.8. Tan 1.8. What would you guess? Where's 1.8 radians? Well, 1.8 radians, ladies and gents, an obtuse angle. It's somewhere into the second quadrant. That's why you get a negative value for the tan figure. The next one is tan negative 2.7. Okay, tan negative 2.7. You are going clockwise 2.7 radians, and that will give you this much of height for the tangent. So they are the values. Now we work that out using the calculator. Okay, ladies and gents, I think that's enough for chapter 14b and c. Work them through. If you get any challenging questions, again email me. I am happy to do a screencast. Until then, I'm going to say have a good one. Enjoy your learning. Thank you.